how do we know when we're learning from a biological organism that we're learning the correct models, right? Since I do a lot of this stuff with scientific machine learning and being like, okay, here's now the software to be able to do this, it's a nice connection to be able to say, hey, look, we got software that is supposedly able to do this, and we also, here's how we know when we're doing this correct. They don't necessarily align because, what you can prove theoretically doesn't quite match what we can do in practice yet. But, what is the gap? Where is that gap? What are the problems that need to be solved? I think that there's been a lot of really great discussions around especially these points, along with other points about, how do you just scale models to be big, right? And I mean, there's this big part about MACSYS about, let's build a whole cell model, right? Whatever that means. And I think it's great, part of the discussion is what does that mean? How do we define it? What are the issues involved? And, so I kind of have this background about how do you make models big, but I think that there's a big question about what is the model that should be made big, and what is it potentially including? What is it potentially not including? It's a problem that requires understanding the computation, the biology, the applications, and this has really been like a nice overview of where the kind of field is at, and where I can kind of lend my expertise as well to kind of say, well, here's what we can make computable, right? And trying to find where that middle ground is to say, what is a whole cell that we could create, with today's world and today's toolings.